Okay. So today we'll start by looking at we're going to graph quadratics in two other forms, right? So yesterday we talked about standard form and how to graph when your quadratic was in standard form using the x equals negative b over 2a, and then that gives you the x coordinate for the vertex and the axis symmetry, and then going from there, right? Okay. So vertex form. Okay. This is our very familiar transformations, okay, with parameters and stuff like that. So you remember here, right? What is that plus k parameter going to do to our graph? Yeah, move it, shift it up or down, right? Move it, yeah, up or down along the y-axis there. So yeah, that's a shift up or down, right? And I'm gonna like abbreviate these. Okay, what's this h parameter going to do? Shift left or right, okay? And the opposite thing that we ran into with absolute value, right, where you have x minus a number, really shifts things right that much, and you had x plus a number, really shifts things left that much, okay? So it still has that opposite kind of property to it that we did in the absolute value. So shift. Okay, and then what does that a parameter do?
Vertical stretch.
Yeah, vertical stretch or shrink, and the flip thing. Kind of, so it does. The horizontal plays into it too. Mm-hmm. But when a is positive or negative, it also flips. That's the other thing I was really looking for there. Yep. Okay, so stretch / shrink vertically, okay, and / or flip over x-axis. In fact, we've already been using that, right? We knew that if our a value, and by the way, that a, right, that a is the same a in standard form, right? The ax squared plus bx plus c, that's the same a as this a right here, right? So we knew that in standard form, right, if we had, I don't have it, oh yeah, right here, right, our little height for the baseball there, it was negative 16 was our a, right? So we had a parabola that opened downward, it was concave down, right? So if a is positive, concave up, a is negative, concave down. Okay? So just like in standard form, right, where when we want to graph things in standard form, the main point we want to identify is that vertex. In vertex form, the main thing we want to identify is the vertex. Okay? So in this context here, right, if we're shifting right or left h units and we're going up or down k units, what will the coordinates for our vertex be in terms of these parameters up here? HK. Exactly right, Dylan. Yeah, h, comma, k, right? We're going to go, in this case, right h units and then up k units from the normal, starting point of 0, 0, right? The origin is 0, 0, and so our vertex is going to be hk, which then would mean that our axis of symmetry, again, that I'm just going to abbreviate here. Our axis of symmetry will be the vertical line x equals what? H. Yeah, the x coordinate of the vertex. Okay, x coordinate of the vertex. Excuse me.
Just a quick one.
Question.
So for h, would it be with the negative or not with it?
So in this form, okay, h is going to be like your shift, like it's going to be your x coordinate. Okay, so this takes care of situations. So for example, let me do a problem and we'll take a look at that. Okay, so we'll get into it because I think I see what you're trying to say, what you're going to get at here. So let me just try this. So let's try this one. So we're going to graph. Okay, let's do this. Yeah, graph y equals negative x plus 2 squared plus 5. So Christian, what is h in this problem?
Negative 2.
Right, negative 2. Okay, because this is not it's not quite the appropriate form, right? We have x plus 2. For our vertex form, we really need x minus h. So in other words, this is the same as saying x bless you minus negative 2, like that, right? And so then our h is going to be negative 2. Like this says to shift left 2. That's going to left 2. Sorry for you guys this way, and so it'll be a negative 2. Okay, so does that answer your question? I think now, yeah. Okay. So yeah, this is super easy, right? No calculation necessary. We know the vertex right off the bat, and it's at negative 2, comma, what's the y coordinate for the vertex? 5, yes, 5. Very good. Right there, the k. Okay, we can give the axis of symmetry too. Just go ahead and do it here just for completion's sake. All right. So let's go ahead and graph this, what we've got right now, and then we'll see what else we want to figure out here. So let's see here, negative 2, 5. So I'm going to be more to the left. Let's see if I do something like this. Okay. So let's plot that vertex, negative 2, 5. So negative 2, 1, 2, 3, 4, 5. I guess I can draw the axis symmetry if you want to here. Do this. Okay. So of course we need more points, right? And so this is a case where, again, if you want to go to a table to get yourself some more points, you're welcome to do that, right? So we could do like, x, y, put the vertex in the center again, so negative 2, 5, like that. Okay. And we'll pick some points before and after that. So, less than negative 2 is negative 3 and negative 4. More than negative 2 is negative 1 and 0. Okay. So like Jordan's suggestion, right? 0 is a pretty easy thing to calculate with. So let's go ahead and plug in that 0 first, right? So 0 plus 2, 2 squared is 4. It's going to be a negative 4, though. Plus 5 is a positive 1. So we have 0, 1. There's a point right there. Let's go ahead and do negative 1. Negative 1 plus 2 is 1. Squared is 1. Negative 1 plus 5 is 4. So negative 1 and then 4. Oops, why am I doing right there? Okay. Now, because of that axis of symmetry, we kind of use that to help us here. So if we have the point 1, 4, what other point do we know we're going to have? Because of this line of symmetry we have here, if we have the point 1, 4, what other point are we going to have here? Negative 3, 4. Okay, exactly. 1, 4, right, is on this side of the line of symmetry. So we reflect over, we're going to be at negative 3, 4 as well. So you can kind of keep that up. And, fill in the table there if you want. Okay. So while I always am putting like 5 points on the table, you really only need to come up with 3 points. The vertex, and then 2 points. And then just use symmetry to get the other 2 points if you want. And then let's see here. I have the point 0, 1. So what other point do we have? Right? Think about symmetry, right? If we have the point 0, 1, that's 2 from the x-axis this way, or 2 x's. 2 from the axis of symmetry. So 2 this way.
4, 1.
Yeah, negative 4, 1. Negative 4, 1. And then connect the dots. Question?
Can we graph something that is the a is 1 or negative 1? Can we just count 1 over 1 over 5?
Yes, yes. So, right. If we, yeah, we can do that. And I'll talk about that here in a second, right? So, that a value, if you remember with the absolute value, okay, that a value is like the slope of the absolute value function, right? Because on either side of the absolute value function was a line, okay? And the slope of a line, does the slope of a line change? Does the slope of a line change? No, right, it stays the same. So you can continue to use that slope to count out more points. This, okay, this parabola here, it is not a line, right? It curves. So its slope, and yes, you'll if you continue in math, you'll be able to find the slope of this thing, okay, in calculus, or pre-calculus too. The slope of this is changing. Okay, the slope of this is changing. So we can't continue to use, the a value to get more points. But there is a pattern that Slayman was kind of pointing out here, okay? How do I want to show it here? Well, I'll do it up on the board. Well, no, then it won't be on the video. All right, I'll do it right here real quick. Let me just show you real quick for the graph of plain old x squared. Okay, so again, I'll use 0, negative 1, negative 2, 1, and 2 here. Okay, so for the graph of plain old x squared, right, it's 0, then 1, then 4, then 1, then 4 there. Okay, and I can keep going here too, just maybe to help you see the pattern. Okay, so starting at our vertex, to get to the next point, okay, we go up 1 with the x values, right? And then what's the rise for our y values? From 0 to 1, we're going up how much? Not a trick question, right? 1, yeah? Okay, go up another, or go right another run 1, right? We're going to the right 1. And then what's this next change? 3, right? Go up 1 more here. And what's this change? 5. Okay, and anyone want to take a guess then for 4? From 9 to the next number, we're going to go up by how much? 7, yeah. So we're going up by odd numbers here. Right, 16. Okay. And then likewise, in the opposite direction, we're going up 1, up 3, because of symmetry, right? So symmetry is going to make us go that way as well. Same one. Okay. Now go to this. We have a negative 1 in front there. Okay? And watch the pattern here. Okay? So from our vertex here, we went up 1 to the next point. For our vertex here, what happens? We go down 1. Minus 1. Right? To the next point, we go down how much? 3. Okay? So what does that negative do? What does that negative do? That negative changes the changes, right? It changes how we're changing. Instead of going up by odds, we're now decreasing by odds, right? So minus 1, minus 3, the next one will be minus 5, then minus 7, so on and so forth, okay? And then this will also be true if you have like a 2 in front here or some other coefficient. It's going, if you have a 2 in front for your a value, it's going to double all these. So instead of going up by 1, like we have right here, you'll be going up by 2, and then up by 6, and up by 10, and then up by 14. Okay? So if you want to use that, you can. Test it.
I have some easy ones.
Oh, gotcha. Yes. Sorry, thanks for. So that's the idea. So Slayman, you can absolutely feel free to use that. To me, it's not as like convenient as the absolute value is. So I'm not sure, if it's something you want to use, feel free. Okay, that is kind of how it's going to be. Every rise of one, we're going to, or every run of one will rise, by odds. Yeah, if that helps you, feel free to use that. But also just feel free to go back to the table like I've been doing here, where we put the vertex in the center, pick 2 points before, and then 2 points after, just use symmetry and stuff. Your choice. Okay, but you can kind of do that thing we do with the absolute values. Okay. So, questions on any of that? Yeah. Yes. All right. So let me have you guys try one here then. So here's one for you to try. Let's have you do y equals 2 times x plus 2 squared minus 4, we'll say. Okay. So go ahead and give that one a try. Try to identify that vertex, right? That's the most important point. Make a table if you want to get some more points, right? You can use, Slayton's pattern there that he's pointing out. Oh, feel free to use that. Oh, okay, I'll take those. Yes, thank you. For 0, you're saying? For 1? You plugged 1 in, you're saying? Okay, so let's see. So 1 plus 2 is 3. 3 squared is 9. 2 times 9 is 15 minus. Oh, your vertex is -2. That's the plus 2 there, so -2 is your vertex.
Can I go a little bit back?
So, yeah. Any question? Correct. -2, -4 is your vertex. Right. Okay. There's your graph. Something like that. Okay. I didn't identify the angle axis symmetry. I guess I could squeeze that in here somewhere. Let's see. AOS x equals -2. Right. I didn't ask you necessarily, right? I didn't really specify many directions there. So if you didn't give the x symmetry, that's fine. But you should be able to identify it, right? That's essentially fine. Okay, again, vertex goes in the center of your table. Boom, like that, right? Okay. 2 points before, 2 points after, but you can see by the symmetry, right? You only need to calculate the 2 after points, the 2 before points, and then just use your symmetry to give those points there. Otherwise, okay. All right. I'm going to show you I'm going to quickly show you the intercept form here as well. Okay. So let me do that here because we are running out of time. Okay. So intercept form. Okay. It is a quadratic that's in the form y equals a times x minus p times x minus q. Okay. In this case, p and q are the x-intercepts of the graph. Okay, so in other words, you have the point P0 and Q0, right? Those are zeros, right? All right, those zeros, in fact, I'll just, okay. So I go back to like another graph here, right? So the zeros are where the graph crosses the x-axis. If we think about the graph that we just did earlier, right? So for example, like here are our zeros, all right? The vertex is exactly halfway between the two zeros, right? Vertex is halfway between the two zeros. Okay? So if we could figure out what the midpoint is of those two zeros, we would have the x-coordinate for the vertex. And that's exactly what we're going to do here to find the vertex. So again, in this case, right, you already have 2 points from the intercept form. So the vertex is going to be located at the point P plus Q over 2, comma, and then of course once you have the x-coordinate, you plug that in to find a matching y-coordinate. Okay, so I'll put comma f of P plus Q over 2, right? That's like plugging in the point there. Okay. And again, once you have that vertex, then you can make a table if you need to get more points. You'll already have 2 points because of the zeros, right? But once you have that vertex, then you can again make a table, make a table if necessary for more points. Okay, and then graph. Okay, so I'm not going to have enough time necessarily here to get into an example because I want to be able to give you guys your assignment and stuff like that too. Okay, let's just say hypothetically here, because there will be a question or two like this on the homework. Let's say I wanted to convert this intercept form into standard form, right? If I wanted to convert this intercept form into standard form, what should I do here?
FOIL by.
Yeah, exactly right. Multiply things out, okay? So to convert vertex or intercept to standard, okay, multiply out / combine like terms. Okay, so the same thing, what Dylan said there, is going to work too for our intercept form. Okay. Be careful with intercept form. Don't make the mistake that I see some students make. Okay, because there's going to be a homework question like it. Don't make the mistake that I see some students make with vertex form, though. All right. If you're going to multiply this out, it's not x squared plus 2 squared. It's x plus 2 times x plus 2, right? When you square something, it's multiplying it by itself. So it'll be 2 times x plus 2 times x plus 2, and then the minus 4 on the outside, okay? And then you just, again, multiply it out and combine like terms, okay? We'll take some time to go over this on Tuesday or two when you come back, all right? Your homework, I'll post to Schoology. It's again going to be from that green book, okay? So if you don't want to even bother writing it down, that's fine. It'll be on Schoology, okay? Please shoot me an email if you have trouble accessing the PDF for whatever reason, okay? Because I know that is a thing. So green book, 4.2, page 249. Oh, you know what? I'm just going to put this on Schoology because I haven't given some chance to think about it yet. I don't want to rush through it. So, anyway, it'll be on Schoology. Just check Schoology. I'll have it up by the end of the day, okay? Sorry, I had to leave during my planning yesterday, so I didn't get a chance to finish up this stuff. Okay? But it'll be posted today. All right.